This is my grade 10 chemistry culminating. For this culminating, I will be comparing two different reactions. The first reaction is when sodium hydroxide and carbon dioxide gas react. These two reactants produce water and sodium carbonate. This is an acid and base reaction, which in other words is called neutralization. We will now have to balance the equation. In order for the equation to be correct, the mass of the products has to equal the mass of the reactants. This is following the conservation of mass law. As you can tell, there are two sodiums on the product side and only one on the reactant side, so you need to put a 2 in front of the sodium. This now then gives you 2 sodiums on the products and the reaction side. But it also gives you 4 oxygens on the reactant side and 2 hydrogens on the reactant side. But it all works out because you now have 2 sodiums on the reactant side and the product side, 4 oxygens on the reactant side and the product side, 2 hydrogens on the reaction side and product side, and 1 carbon on the reactants and products. This means you now have a balanced equation because the products and reactants have an equal mass. You can tell a chemical reaction has occurred between sodium hydroxide and carbon dioxide because gas is produced when they are combined. Also, if you add bromolyl blue indicator solution, it will change from being blue in the sodium hydroxide because it's base to green if you add little bits of carbon dioxide to make it neutral. If you add large amounts of carbon dioxide, it will become yellow and orange because it is a weak base. My second reaction is between zinc and lead 2 nitrate. These two reactants produce lead and zinc nitrate. This reaction is a single displacement. As for the other, you have to balance the equation due to the conservation of mass law. But for this reaction, you already have 1 zinc on the reactant side, 1 lead on the reactant side, 2 nitrates on the reactant side, and 6 oxygens on the reactant side. This is equal to the product side, so there's no balancing needed in this equation. The reaction produces lead, and lead has been used and is still used for many things. For example, in the ancient times, it was used for water pipes that date back to the Roman Empire, glazes on prehistoric ceramics, and the cosmetic kohl used by the ancient Egyptians to darken their eyelids. Prior to the 1900s, lead was used in the United States primarily in ammunition, burial vaults, liners, ceramic glazes, leaded glass, paints, or other protective coatings. Following World War I, the demand for lead increased because of the growth in the production of motorized vehicles, many of which use lead-acid batteries to start their engines. Today, lead, which has been mined on all continents except Antarctica, is one of the most important metals to industrialize the economies. The uses of lead today are in ammunition, oxides in glass and ceramics, casting metals, and sheet lead. This reaction is an environmental and safety concern because it produces lead. Lead is one out of 4 metals with the most dangerous effects on the human health. It can be taken into the human body by food for 65%, 20% water, and 15% air. Lead can cause rise in blood pressure, kidney damage, miscarriages, nervous system disruptions, brain damage, declined fertility in men, diminished learning abilities in children, and behavioral disruptions in children. In cars' engines, lead is burned in, so when the exhaust exits the car, the lead enters the atmosphere. The lead will fall back onto the earth through rain. This is called the lead cycle caused by humans, which is more extended than the natural lead cycle. This has caused lead to be a worldwide pollution issue. When creating a compound, there are either 2 or more elements, or ions, in the compound. The relationship is that when you add the charges of the parts of the compound, it is equal to 0. All compounds have a charge that is equal to 0. For an example, you have Na2CO3, which is sodium, which has a positive 1 charge, and carbonate, which has a negative 2 charge. As you can tell, there are 2 sodiums, which means you have to multiply the charge, which is positive 1, by 2, which gives you a positive 2 charge. And then your carbonate ion has a negative 2 charge. So when you add the positive 2 charge and the negative 2 charge together, you get a charge of 0. This follows the relationship that I have noticed between the oxidation numbers and the chemical formula. Since this project is about comparing 2 chemical reactions, I am now going to show you the similarities and differences between these 2 reactions. A similarity is that they both don't have a catalyst, and with a catalyst, the reactions occur faster and require less activation energy. A difference is that they are both 2 different types of reactions. One is single displacement and one is neutralization.